Our next speaker is Vincent Desiderio. He's going to be talking about the analysis of general unknowns.
Good morning. Just a little disclaimer, I'm from New Jersey, so please don't mind my accent. I also got to check if Katie Balance is in the room. You over there? Did your parents miss any other significant life events that I should be aware of before I start talking? Is there going to be like a yellow elephant running into the room and serenading us? All right, thanks. Yeah, I got like 20 minutes, but I'm going to do a 10-minute joke now. Every time I come to these things, people are always doing these little geography lessons. So I figured, hey, I'll talk about New Jersey a little bit. I don't know how many of you are familiar with New Jersey, but we're located up in the Northeast. Got this nice sign here. We got Atlantic City. Has anybody ever been there? It's pretty gross. Great commuter state. We're sandwiched right between Philadelphia and New York. If you've ever flown in, you might see our skyline. Or on the other side of that, the other skyline. Not everything's bad, right? We got Bruce. But we also got Bon Jovi. For the other. We also might have Jimmy Hoffa, who may or may not have been put there by some of these guys, some of our very fine families that live in New Jersey. But we also have the New York Giants, the New York football Giants, Super Bowl champions 2010, right? All right, getting into this. I gotta admit, it's a little bit intimidating talking about this topic because there's probably 350 people in this room who do it better than I do. But I figure I'd come here and talk about it a little bit. Maybe I get some pointers out of it afterwards if anybody wants to talk about it. General unknowns, just stuff that comes in, nobody knows what it is, various different things that might be submitted. Some of the submissions might request things like identification of the contents, what is there, determination if a specific compound might be present, maybe there's cyanide and you want to check something for cyanide, determination of if a questioned substance is comparable to a known, you have that comparative mindset going. And then there's cases where you get it for some other reason and it's a routine case, but it takes a little bit of a turn. Anybody ever see this stuff before? This is a paint case that I had hit and run. There was no damage on the individual, on the clothing, but I scraped it down, I collected this stuff up, and on just about every item of clothing, I found these little particles. They were extremely tiny. I apologize for not having a scale in there, but you're talking about maybe on a scale of about 1 millimeter a piece. They're layered, have a lot of color, it looks kind of printed. Anybody ever seen this before? Do you know what it is? No. I was racking my brains out over this for about 3 days, and as trace evidence examiners, you could probably all appreciate this. When you see something, you just don't know what it is, and it kind of just sticks around in your head. About 2 days later, I was laying in bed, and I don't know why it popped in my head. I was like, I think this is residue from a scratch-off lotto ticket. It's like I couldn't sleep that night. I'm like, I gotta go to like a bodega and buy a scratch-off lotto ticket tomorrow. As luck would have it, I was walking my dog the very next day, and I found a couple that somebody must have tossed out of a car. So I brought them into work. I scratched off the remaining residue. And once again, I apologize for the quality of this photo. I'm not a really great photographer, but pretty much the same kind of stuff, right? I don't know. I thought that was interesting. General unknowns, just like any other trace evidence, provides a lot of different things. It's not just linking suspects and victims and scenes. You can also get information that provides proof of a criminal act. Maybe it's some illegal substance that somebody shouldn't have in their possession. Provides investigative leads. What is this? Where could it have come from? Maybe you can help narrow down a location. Could be used to support or refute a story. Same thing with reconstructions. Did two things come into contact with one another? Is there a transfer of this unknown material that you might be able to identify from one surface to the other? Some common submissions that everybody pretty much encounters. The big one's unknown powders, right? You get a white powder. What is this stuff? You get unknown liquids. You can have mixtures. Items with unknown residues on them. I've had shoes come in that had something stuck to the bottom of the shoe, and that same material was left at the scene, so they wanted it identified and compared. You can have solids thought to contain adulterants, liquids thought to contain adulterants. Usually that's kind of the food stuff cases. That could be quite challenging. Some common analytes, there's a whole list of things on here. Could be looking for inorganic salts, building materials, acids, bases. Why do people like to throw acids and bases in each other's faces. I never quite understood that. Bleach as well. I'm going to throw bleach at you. I don't get it. Volatile organics, just random schmutz, anything that might be submitted from an environment. Some general considerations. These things are unknown, right? So you don't know what they are. You don't know how safe they are. So you really have to consider that. You don't want to put yourself in danger or anybody else in your laboratory environment. So you just got to throw that in there. You got to use your proper personal protective equipment, work in a hood whenever possible. Is there any background information that might help you identify what this material is? I have an example of that coming up in a second, I think. I do want to stress this next point. Analysis requires a well-thought-out approach. There's never really any one single way to approach these things. You have to take in some information, think about what you have, and approach it from that type of situation. That being said, everybody's going to be doing something a little bit different. So the way I do something might not be the way you do something, but the goal is to just come to the same conclusion. I like these cases because you often utilize every available resource in your laboratory. You have all these instruments sitting around. Some people are like, we shouldn't have spent all that money on that thing. This gives you an opportunity to justify the existence of a lot of the instruments you have. I'm being serious. The other point is, it's a general unknown. It can be literally anything from the environment, but there's a lot of mass-produced things out there. So it could be it's most often something that's very common. There's just a simple little case that I had. Background was there was a suspect. He was an illegal alien looking to purchase a large quantity of ammonium nitrate. This guy was going to probably blow something up, right? There was a white powder found in his vehicle. Did a visual stereomicroscopic exam and indicated it was a very fine, uniform, crystalline material. I just went and I did an elemental analysis on it, and it came up with a little bit of magnesium, a little bit of calcium. So the elemental profile indicated the presence of lime. And this was confirmed using X-ray diffraction. So this guy wasn't going to blow something up. He was probably just going to make somebody's lawn a little greener. He was actually a gardener trying to purchase some fertilizer. I like to talk about this analytical funnel. You get these cases and you start way out, just very general, broad. Then you want to take all the information and gather it up as you go along and narrow that funnel down. With the goal of getting to the point on the funnel, a little tip at the bottom where you get molecular identification. You identify the substance that's there. So you start out using just general observations and general procedures, and then you get more specific as time goes on. So some things you might do during the general observation period. Note the packaging. Is it a mass-produced item? Is there packaging? Is there information on the packaging? Maybe there's some investigative information, lot numbers, things that you can trace it back if that's necessary. Are there markings? Was it processed for fingerprints? What's the state of the sample? Solid, liquid, gas? Is it a mixture? What type of mixture do you have if it is a mixture? Heterogeneous, homogeneous. If you have a liquid mixture, is it a biphasic or multiphasic liquid? Is there a color in there? The general amount of the sample that's present. And something, I don't recommend you sticking your face in anything and inhaling to get an odor. But is there an obvious odor coming off of something? When you open up a can or a box, is there acetic acid odor coming out or something that might be important? And I have a decent case example of that a little bit later. I had about 15 slides that I was going to bore you to death with on the general approach to solids, but I just kind of condensed it down to this one slide so I wouldn't bore you as near to death, I guess. But you start with a visual general examination. You move to your stereomicroscopic examination. At this point, if you're looking at solid, you try to determine if there's crystalline materials there, if there's a mixture of materials. Maybe you're trying to separate out some particles from the matrix. I have a case example I'll talk about on that in a second. Then you could proceed with things like polarizing light microscopy. I just want to mention that microscopy is the soul of trace evidence. You can get a tremendous amount of information. Everybody knows it's non-destructive. Some people can identify all types of compounds with that. I'm not that good with it. I strive to be better. I don't know if I'll ever get to the point of some of the people in this room, but it's incredible what some people can do with just a microscope. I like to go to elemental analysis. I think it's a really great way to get a lot of information from a sample, screen a sample. Right off the bat, you'll know if it's organic or inorganic. Then you can get whatever elements that are there if it's inorganic and use that information for later analyses, especially when you go into FTIR, XRD. So after elemental analysis, might narrow things down a little bit, you go into compound identification. I should exit out here and put a comma next to FTIR and put Raman in there. Not everybody has it, but it's obviously a great technique, as we were told this morning. I like to do a lot of, if you have organic compounds, mass spectrometry, if it's a volatile compound, or something that has a high vapor pressure, you solubilize it and dilute and shoot. If it's a macro molecule or polymer, then you can use PyGCMS. I've also found PyGCMS useful for mixtures. If you want to separate out, make very complex mixtures, you can get information from all the different components in the sample. It's a great separation technique, and then you get some pyrolysis information along with it. A lot of additional tests are available. You have all your chemical and microcrystal tests. Everybody have Chameau and Mason. Comes in handy all the time. You know, you get stuck on something, you need to confirm it, go right to that book. It's a great resource. Ignition tests, something as simple as trying to light it on fire. Simple and fun is trying to light something on fire. You get a decent amount of information out of that. You know, is it an explosive material? Who knows? Liquids, very similar approach. Visual general examination, odors, colors. I like to do a pH, and that's good if it's an acid or a base, obviously. I like to do conductivity as well to see if it's an ionic liquid. Ignition tests. Maybe it's something that should be sent to fire debris. Maybe it's an ignitable liquid. Is it a mixture? Do you need to extract it? Is it a liquid-liquid mixture? Is it a liquid-solid mixture? Are there any precipitates there? You can do a quick check if you have plenty of liquid available, just evaporate a little bit off, and then if you have a solid residue, just go right back to the solid procedure and analyze that way. And I get into the sample screening and the identification of components. And I'll skip right over FTIR for the moment. But GCMS, if it's an organic liquid, you know, great technique. Once again, PyGCMS as well. FTIR, any of the residues, you can do liquid. If you have ATR, it's very useful for something like that. Elemental analysis you can do on liquids. And I think I have the slides in here. I'll show you that in a second, what I do. Chemical tests, precipitate reactions, very useful. I don't know if everybody does anything like this, but if I'm looking for an acid, I can take a swab, just dip it in the acid, wrap that swab in a little bit of polyethylene, and then use X-ray fluorescence without the vacuum. And right here, you can see you have a nice chlorine peak. And then if you run a blank swab, all you see is the argon. Remember, we're running out without vacuum, so you'll pick up the argon. The instrument is sensitive enough to do that. So I found that pretty useful. Gases, rarely encountered in my experience. I don't know about everybody else. Usually it's something to do with fire debris where they just want to check a lighter to see if there's butane in the lighter. It's a butane lighter, maybe. But GCMS, you can do headspace techniques on that. FTIR via gas cell is also useful as well. Some special considerations. You need to consider any chemistry. Maybe there was something that reacted, or maybe there's a reaction that's occurring. Maybe you can trace back that reaction to the original starting products. It's important to have controls and comparison samples. You know, if you want to try to identify something and then compare it to a certain product. Hydration states are important. I have a case coming up in a second on where that became important. If you're going to run X-ray diffraction and your sample was in a very humid environment and then you have a control sample that wasn't, it's going to have differing results. So maybe you need to desiccate it, bake it out, and then do the comparison that way. Hydroscopic salts, if you do, I like to do a lot of X-ray diffraction, but if they're drawing water really quick from the atmosphere, you can dry things out, coat it with a little mineral oil, and then run the sample that way. Prevents all the moisture from getting on the sample. Small amounts of sample, you can scale down your tests. You can do just a little bit of microscopy. You take those chemical tests that you might be doing in the spot plate and then put it right on a slide and observe the reaction under the microscope slide. You just keep concentrating little drops on there and do the reaction. Somebody said this yesterday as well, rely on others. You're never gonna have all the answers, and there's some people out there that might have had the same type of case that you're working on at the moment. Call around, ask questions, rely on other people. And then sometimes it just doesn't work out. And you get to get those cases that you just can't figure out, and they'll stick with you forever. And then maybe one day, 10 years from now, hopefully like light bulbs will go off. But I've had cases, and it's a little depressing because you can't finish it. But sometimes you just can't finish identifying something. Just a couple quick case examples. Anybody ever see this? One of the first cases that I worked on involved a weightlifter who suspected his wife of poisoning him with OxyClean. She was putting it in his muscle-building powder. It was just kind of a weird situation. So there's the OxyClean. So I had to sift through this huge container of this, what is it here? The Beefcake 4000, we'll call it, to look for these little crystals. And it took me about a day and a half to get enough material out of there. But there were 2 different morphologically distinct crystals that I was able to separate out and identify. But it took a very long time. It was a very tedious process. With that in mind, I recently got this case. Suspect is accused of adding cupric sulfate to instant coffee. And this is what it said on the receipt. And I found that a little bit odd. Like, hey, who just has cupric sulfate lying around, So the guy gets up, makes himself a cup of coffee, and it doesn't really taste very good. So we get the materials in the lab, we got some of the coffee, and we got it was an instant brand coffee. So I'm sitting there with an intern, I'm talking about my Beefcake 4000 case and how tedious it was, and then I'm gonna have to sit here looking through this Nescafe container for like 2 days. If there's anything in there, picking out little blue crystals. I open it up, and that's what I see. I realize that some people are extremely tired before their coffee, but I mean, how tired can you be not to realize that something like that's in there? So the intern's like, wow, it's very cool. I think there's cupric sulfate in the coffee. But this case is the one I had to worry about the hydration states. The samples that we had for comparative purposes, and just to identify the cupric sulfate, I had to dry it out and do X-ray diffraction. This is a simple little one, the anarchist. There was a kid walking around, he had a little, what I called an anarchist cookbook sampler. So he had his plastic water bottle with a white slurry and aluminum foil, a little chemical reaction bomb that he had made. Skip to the incendiary. He had this little incendiary device that he made with a sparkler and a little metal capsule. That was analyzed for fire debris, gasoline was in there. But they also had this gray powder, which was submitted as an explosive powder. So I did my visual stereomicroscopic examination. There was some gray and beige granules, some clear crystals that had a rhombohedral shape. Ignition test, we had to do that as our standard explosives procedure. There was nothing. I didn't think I would see anything. And then I analyzed using XRF and SEM EDS. Here's the gray powder. The first thing I saw, I thought like kitty litter or something like that. But here's the data. There's a little bit of arsenic in there, which I found, that popped up. I don't know, wow, arsenic. Why is he carrying around arsenic? So I took a closer look at the clear crystals. That characteristic shape of sugar, just confirmed the presence of the sugar using IR. So the kid had to make sure this arsenic and sugar, which was indicative of rat poison. When's the last time you've seen rat poison with arsenic in it? It's a long time. So the kid wasn't really trying to blow anything up. He was just trying to probably poison somebody. Lunch. Anybody hungry? This is always a recurring theme, so I think my wife might try this someday. Why is the wife always trying to poison the husband? I don't get it. Husband suspects wife of poisoning his prepared lunch consisting of buffalo-style chicken wings and coffee. And I know what you're thinking. That's not the poison. That's a deadly combination, especially if you got a long ride to work. But it was lovingly prepared. A nice microwave container, a little bit of coffee. There's the chicken wings. They smelled delicious when I opened them. Did a little analysis on their voltage. Open it up, you can smell it right off the bat, but detected a medium aromatic product in there. Those of you who are familiar with fire debris. Took a little look. I can't point it out, but there's a couple of little peaks down at the end there. Try to analyze these, determine what they were, and they turned out to be permatrinic acid, which is a component of permethrin. I believe it's a breakdown product of permethrin. So there was a little bit of insecticide in there. I thought that was interesting. And then the last case I'm going to talk about, do I have time? All right. My Glade case. This was a fun one. Nothing of a big deal, but I had a really good time doing this case, and there was a little bit of validation at the end. Background on this is there's a partially decomposed female victim found in the basement of a boarding house covered with a white powder. Victim's husband was the suspect. A sample of the white powder is collected at the scene, submitted for identification. They wanted to know what this stuff was that was all over. So the prosecution theory was the husband killed his wife and hid her in the basement. This is Dr. Bennett this morning. I don't think she meant to go to sleep in the basement, right? Covered her with this white powder to hide the odor. Received the white powder in the lab, opened it up, and there was a sweet, right as soon as I opened it, there was this sweet, distinct odor. There was a little bit of decomposition odor on there as well, but there's this sweet, distinct odor. So I tried to do a little bit of analysis on it, did my standard solid protocol, visual stereomicroscopic examination, my elemental, I did FTIR and XRD, and what I found was that it was primarily inorganic containing sodium sulfate. So I did a little bit of background research, indicated the possibility that it was used as it was a carpet deodorizer. You had the odor, you had the sodium sulfate. So I went to our reference collection, which is ShopRite across the street. You all got these, right? Lowe's, Home Depot, ShopRite, excellent reference collections. I looked a little crazy, standing in the aisle, sniffing at different bottles. The manager's walking by, I see the cameras trained on me. What is this guy doing? 20 minutes sniffing different carpet deodorizers. I found one that smelled pretty much the same. So I purchased it, I brought it back to the lab, did the same analytical protocol, and then I went and I extracted both and performed GCMS for any, any organics that might have been present. And I observed that they both contain jasmine oil, which is a common scenting compound. So my report goes out that the white powder contains sodium sulfate and a fragrance component. Substances which contain such mixtures include but are not limited to some carpet deodorizers. Here's just some of the data. And I can't point out the lasers, there's two screens all over the place, but you can see how well they overlap with the inorganic components. Here's the IR, just a little bit of a slight blip difference there. Here's X-ray diffraction, the overlay of the samples. And here's the GCMS. And you just have to keep in mind that there's some extra components in the sample that was on the victim, plus there's probably a little bit of loss of some of the more volatile components as well. You can't make that out, but this is the jasmine oil. And then a lot of these other compounds were also the same exact thing. There were a lot of the same organic compounds that were in there. So in validation of this case, it was good to know that after it all occurred, the suspect did admit the fact that he used carpet deodorizer to hide, which is pretty much common sense. He's covering the odor of the person, so he used carpet deodorizer. But I thought it was a fun case. I testified on it, and it was one of my more fun cases. Just a couple quick resources. If you're doing a lot of mass spectrometry, most of you are probably familiar with this, but NIST has a really great web page. You go on there, you can input information. It'll help you if you're stuck and you're not getting a good library hit and you want to try to identify something. This is a very good resource. You just input the information, it'll give you a mass spectrum. There's also the spectral database for organic compounds, which is pretty much complementary to the NIST one. I found it very useful. And I'm sure most of you have also seen this by now, but the household products database, which I think is pretty cool. You go in, if you have a compound that you've identified, you just punch it in there and it'll come up with a list of products that might contain it. And here's 2,000 flushes, automatic bowl cleaner, nice. Made by WD-40, there's the MSDS sheet, there's a lot of background information. So they're on there, this will all be on the website. Acknowledgements, I'd like to thank my admin for giving me the opportunity to come here. That's Howard, Ajit, Jackie, and George. I'd like to thank my coworkers for letting me hang out with them this week. you know how overbearing I can be. So Melissa Balo, Stu Hong, Jane D. Michelle. I'd also like to thank Cassandra and the steering committee for giving me the honor of coming up here to be able to talk today. Jocelyn Williams, you read the last line, didn't you? Jocelyn Williams for all the work that she's done. I'd also like to thank Katie Balance back there and that pink gorilla guy that came in, gave us all a lot of entertainment, and gave me a lot of fodder for some jokes this whole week. Thanks for being a good sport, Katie. Do we have time for questions?